So let's just start with why do we have this issue with having to modernize roles, and why are there so many new roles, and why is there so much change? And it's pretty simple. The underlying root cause of this is how complex the world of analytics and data science is today compared with years past. So in the early days when I got into analytics, it wasn't actually even called analytics yet. It was just statistics. There was no such thing as business analytics for the most part. And there were a couple of tool sets that everybody used. It was pretty much SAS initially on a mainframe, then eventually relational databases became a big thing, and we started using a lot of SQL to prepare the data before feeding it into SAS. But there were pretty much just a handful of platforms. The data was all pretty much standard transactional style data, whether it be sales transactions, ERP data, really basic data by today's standards. But of course, back then with the storage systems and the processing capacity, those were huge challenges. Well, over the last decade, we've had the explosion of big data. We've had the explosion of the open source movement. We've had all the different data types ranging, audio, video, et cetera. And then even the tool sets. Obviously, it's no longer just SAS and SQL. You've got R, you've got Python, and all types of other tool sets out on the cloud. And so the problem is things are just much more complex in terms of the tool sets. The skill sets are much more varied as we'll go through. There's so many different types of analytics today. We'll talk more about that. And then even just the platforms. There's not just cloud platforms, but multiple different cloud platforms. They each have their own ways of doing things. And so it makes it very, very complicated to build analytics processes and do it correctly, particularly if you want scale, which of course today folks are focused more than ever on the scaling of those processes. So that's what's led us to do it. So in the past number of years, let's say traditional analytics professionals, right? So folks like myself, I'd include in analytics professionals anyone from data scientists, people building models, even down to let's call this people who for a living are doing lighter analytics, but people who focused historically just on building analytic processes. A number of things have changed even within these existing roles. So there's a lot more focus on a strategic architecture versus specific technical specs. And what I mean by that is with some of the tools that are available today and how flexible they are, you're able to basically drag and drop widgets around on a screen, connecting a data source to an algorithm, grabbing the output, putting it over somewhere. So much of the technical details can be taken care of for you with a tool that you get to spend more time kind of laying out and architecting the process that you need to build from a logic flow perspective, and not having to do quite as much of the gory detail coding and such that used to have to be done. As we've automated some of the generation of these analytical and data processes, of course, what ends up happening, we create more, but now we have to manage them. And for a while that was sustainable, but you quickly get to a point, and I know even when I was still very hands-on earlier in my career, every job I ever had, I'd start out building some really cool new analytical processes, and then I'd end up having to spend over half my time managing and maintaining those, which wasn't necessarily what I was wanting to do or the best person to do. And we've gotten a lot more mature about this, but as an analytics organization, while it may be that you have different people that will handle this, you still have to do it, and you're spending a lot higher percentage of your time managing these processes on an ongoing basis, as opposed to purely creating. And then another interesting twist is this idea of a post-algorithmic era. We talked about this at IA probably about 3 years ago now. This doesn't mean we're moving past algorithms at all. Obviously, we're using algorithms more than ever. But what it means is for a long time, having access to algorithms and knowing how to use those algorithms was a big competitive differentiator. So again, back in the early days, you had to know how to log onto a mainframe and code. Back then, it was a pure coding environment in SAS if you realistically wanted to do any type of scalable analytics. And that was hard. So you needed someone typically with advanced degree, like, my degrees are in statistics, a lot of coding experience to even get access to those algorithms. So when you apply for a job, the fact that what a regression is and how to go run one actually stood out. Well, as algorithms have become ubiquitous, you can go get most standard algorithms now, even within tools like Excel, and certainly you can get them out on the cloud all over the place in various packages. And so simply knowing what an algorithm is and how to access it isn't a distinctive advantage anymore at all. What's become much more of an advantage these days is that ability to understand what do all these different algorithms do? How can I put them together and maybe chain them together to make one analytical process that does a whole lot more sophisticated levels of analytics than was done in the past. It's knowing how to do some of these things around designing and laying out these processes. Simply having the technical ability to access the algorithms just doesn't matter anymore like it used to. And so what this means, and as I go through these various roles in a little bit here, you'll see it's kind of like evolving your analytics and data science organization, much like the medical field has evolved. But what I mean by that is if you were to go back, even 100 years, as particularly if you go back a couple hundred years, you'd have maybe a town doctor in a small town out somewhere. And that doctor would literally treat you for everything from a sore throat to a broken bone to doing surgery. Now, by today's standards, we'd be horrified at the idea of a single doctor trying to do all of that. But you have to remember, at that point in time, the technology and advancements of the medical field were nowhere near what they were today. And that those individuals could probably do a reasonable approximation of the best available medicine in that day and age, given where things stood. I think this is a lot about where analytics were when I first got out. The number of algorithms was smaller, the types of data were smaller. The amount of scalability we had was less, so we had to do much more targeted and focused processes that were, almost exclusively batch processing based on the limitations we had. And that wasn't quite as big of a world to have to tackle. So you could take somebody like myself and just say, okay, we're going to hire, quote, an analytics person, and they're going to come and do whatever we happen to need to do. Problem is, let's go to the medicine analogy again. As the medical field evolved, you started to have doctors specialize. So these days, you've got not just a doctor, but you might have a cancer doctor, but not just a cancer doctor, you might have a brain cancer doctor, but not just a brain cancer doctor, you might have a pediatric brain cancer doctor. And not just a pediatric brain cancer doctor, but maybe a pediatric brain cancer doctor that specializes in certain types of children's brain cancer. And so when you go today to a medical office, when I was young, we would just go, it was typically literally an office. You go to often, it was an old house converted to a doctor's office with a couple rooms. There'd be a doctor and they'd pretty much see you for most things. And if they needed to refer you to a specialist, they would. Today, you now have these large office buildings that are filled with a single medical practice where they've got gastroenterologists, they've got allergists, they've got radiologists. They have virtually all the types of specialists so that when you go there, you can in a one-stop shop have the people that you need. At the same time, we still have general practitioners because those general practitioners are the first line of defense where they can go, they know enough about all of the specialties to say, all right, given what I'm seeing with you and your medical state, I'm going to refer you over to this specialist or that specialist, and I'll kind of help shepherd you through your care cycle. That's where we are today with the world of analytics and data science. It's not just about being, quote, an analytics professional or a data scientist today. You've got people specializing in natural language processing, not just natural language processing, but specific types of natural language processing. You have people specializing in, classic predictive models. You have people specializing in image recognition of one type or another. The point is we have all of these various specialties, and they're so deep and complicated in and of themselves that you can literally spend years just diving deeper and tackling problems within those specialties. And so what you have to do is start to recognize you're going to have your generalists who are going to help with some initial scoping and understanding of the business problems, maybe help farm out to the right specialists and so forth, but you're going to have a broader range of teams and skills. So this can be incredibly intimidating. And I often have people at companies, not as much anymore, but not too long ago, they'd ask, well, does this mean I have to fire everybody I have and go hire new people to get into these new specialties, right? So I don't have anyone who knows natural language processing. I have to fire somebody and hire someone who knows it. And I always make the point, no, for the most part, you don't. And I'll use a sports analogy here, right? We could go out, and if we took people who have never seen a game of basketball or a game of soccer, and we took them out and had them watch some kids play, within a few minutes, if you didn't even know the rules or how the game worked, you know which kids were good and which kids weren't, because the kids who are athletic and who are good at sports will stand out very quickly. And the reality is, if you take a pro athlete today or an Olympic athlete in any given sport, chances are they're going to be pretty darn good at most any other sport that you put them out there to play. Maybe not Olympic level, certainly not right off the bat, but you take a professional basketball player, throw them on a soccer field, they'll do better than the average person by far. So the point being that there's an underlying athleticism, and that's what matters. If we have a highly athletic person, we can cross-train them in multiple types of sports, and they'll probably get really good at a whole lot of them. If you have someone who doesn't have a natural athleticism, you can give them top coaching for 10 years, and they're never really going to be all that good. They'll maximize their own potential, but they might not ever make it out of a house league team. This is the same concept then with analytics. I call it analytic athleticism. There is a certain way of thinking and a certain way of putting together an analytic process and the logic of what you're supposed to do for a given problem. Some people have it, some people don't. The people who are really good at laying out these processes, at coding them, they can go learn another language, they can go learn another algorithm if you give them the time and the training. And in fact, they're probably really excited to. So find those natural people who are awesome. And if they're interested in learning some of these new tools or algorithms or technologies, go ahead and let them have at it. And you probably wouldn't have to really hardly let anybody go. The people that you might need to let go are those that you have that were just barely good enough at analytics to just barely do the basic job you had for them at the time you hired them, and they just don't have enough skill to move beyond that. In those cases, you might replace them. But you can make a heck of a lot of progress just with the people that you have. So tied to this, I already mentioned this. One of the most common questions I get from students is, which language? Should I go learn Python? Should I learn R? Should I learn SQL? Should I learn SAS? Which is best for me to get a job? Where I have, companies will say, back to the same point I just made, I've got a bunch of people who've been programming SAS for 20 years. Do I have to get rid of them and go hire people who know R? The answer is fundamentally no. If you're a really good programmer, the hard part of programming is understanding what needs programmed, how to lay out the logic. It's not putting together the syntax. So let's think about speech and writing in our own language. If you're a 2-year-old learning to talk for the first time, it's really, really hard when you have no idea what a sentence is, what a verb is, what a noun is, what the grammar rules are, and you've got to learn how to put all that together and actually communicate to people. That's really, really, really hard. And that's the equivalent of when you first learn to program. You're learning entire, how is code structured? How do you chain it together? What's efficient? What's not? That's like the first language that you learn is like that toddler. But once we know a language, it's much, much, much easier to learn another language. If you told me today that I had to go and let's say move to France for 5 years, and I personally today don't know any French, certainly it'll be a challenge for me to learn French, but because I understand language generally, I'll know exactly what I want to say to somebody in French. I just have to get together in my head, what do I want to say? And then just figure out the specific syntax in French to say that. Same thing with programming languages. If you have somebody who's a rock star coder in Python, I can promise you with a little bit of practice, they could be a rock star coder in R because they'll know exactly what needs to be done. They have the hard part. They get the equivalent of the sentence structure and the grammar rules and so forth. They just have to say, okay, how would I make this specific Python code I can picture in my head work in the syntax of R? So keep that in mind as well. And I encourage people younger in your career, get to know as many languages as you can. However, because it never hurts. However, if I'm interviewing people, I always said, I want to know that you're really good at one language, and then I'm confident that'll transfer. If you kind of know a bunch of languages, it's hard for me to know if you really are good or not, because you haven't shown on any one that you're really good. You just know a little bit about a bunch. Which then brings us to another thing to keep in mind with all the roles we'll talk about. There's a lot of hype these days, and everybody wants to be a data scientist or a data engineer. And you can see people putting on their resume. I've seen, for example, even some of the students coming out of universities they will have had like one really basic analytics course as they got their business degree or some other degree that specifically was not an analytics or data science degree. And then their resume says they have a degree in analytics or a focus in analytics or something. And they go and interview for a job. And, I feel sorry for a company who doesn't do good screening to realize they really don't know much. But even if you do, here's the thing to keep in mind. I'm not very good at art. I can't draw or paint worth anything. However, I could go take an art history class or an art concepts class, classroom based, where they teach me all about the different kinds of brushes, all the different kinds of paints, oil-based, water-based, different styles of painting, modern, classical, all sorts of different styles. And the point is, I could even pass a test and maybe get an A in that class because I'd understand what all the brushes did. I'd understand what all the colors did. I'd know when you do mix this, you don't mix that. I could describe that all day. However, doesn't mean I'm good at actually applying that knowledge. You really need to make sure that people have done and can demonstrate they know how to put to work the skills that they've learned in a lot of these certificate courses or even degree programs, right? They may have the theory, but they know how to apply it. Here's Bob Ross. For anyone who's never seen him, I think it's either Hulu or Netflix now has a lot of his old episodes on. And I remember this from when I was a kid. I saw some of these. He's fascinating. He has a half-hour show where he starts with a blank canvas and in real time will paint a picture that looks just like this one here. It's different every time, but that complicated in a half hour. And he explains to you exactly what he's doing at every step, the brush style, the color, the technique. And I can tell you, if I sat down next to that TV, even if I freeze framed it and did it at a tenth of the pace and try to do my best, my painting would look nowhere near that good because I just don't have that underlying capability. So whatever you do, as you look to hire and as you look to get people into these new roles, just remember that, you know, taking a quick online course or getting a certificate or saying that you've done some studying, until you've seen them apply it, it doesn't really count for much. So with that, let's get into the roles today. What are some of the specific roles? And there's more than I'll cover today, but I'm going to cover a couple of the biggies. First one, data engineers. This is, I don't even know if this qualifies as new today, but it's certainly still growing. Didn't hardly exist just a handful of years ago. Now they're all over the place. Talk a little bit about that. Analytics or data translators. That's a pretty hot discussion point these days. Analytics interface application developers. I'll go through those. Various operations roles that are probably some of the more recent arrivals. And then chief data scientist / I'll call this a technical fellow of sorts. I'll explain what they are. So I'll go through each of these in turn and then kind of tie it together. So let's start with the data engineering. What brought on the need for data engineering? This is something early in the days of data engineers I found myself asking because for many years we didn't have it. And what I've come to the conclusion of, and I've written some blogs on this, is that if you went back even barely 10 years ago, if you were a data focused expert, you would have been in one of three areas: source system, ETL, or platform. And so source system would be you actually worked in, say, a point of sale system to help manage the data within a point of sale system operationally. ETL were the people who would sit and pull the data from that source system, apply logic to then load it into a platform somewhere, typically a relational database. And then you'd have your database administrators who would then administrate that data within the relational database to make it available. And there were relatively few point of sale systems that were relatively stable in any given industry. There were a couple of very well-known enterprise ETL tools and a number of large-scale database platforms. And so it was fairly stable, that whole world, for a number of years. But as we talked about earlier, suddenly big data hits and we've got different data types. We have more scalability. The cloud hits. All of a sudden, while we still need all of those data roles I just talked about, we had entirely new needs. And this is where data engineering suddenly came. And so in reality, especially in the early days, a lot of what data engineers were actually doing was just, almost in a panic, trying to figure out how can I chain all of these brand new open source tool sets together on this brand new cloud-based platform and tie in some data from the on-premise system and actually get a process that'll go end to end and work. It was almost like those Rube Goldberg machines where you see like 100 random steps happen one after the other to make something, like filling a glass of water happen. And so what you had was really smart people having to get in and just get their hands dirty because these tools weren't well documented yet. They weren't that mature. There were so many of them that maybe nobody had actually used the exact set of tool sets that you were using in the exact way that you were using them yet. So you were chartering a lot of new ground. So that's really, really, really hard. Sense the need for what we ended up calling data engineers. Another key difference to the old days is if you go back a certain period of time, we had a so I just want to make sure I didn't get disconnected here. Nope. Okay, sorry. I thought someone had said I did disconnect. If you go back not too far, then the traditional data experts really focused on optimizing processes within their own continuum. And it was a handoff. The source system kept that optimized, gave it to ETL tools to optimize the transforming process, who gave it to a database administrator. Data engineers are much more focused on optimizing across this disparate set of tools that they've chained together. They may be able to optimize within the tools okay as well, but it's really that bigger view. So it's a little bit more strategic, a little bit more heavy lift role. What that brings us next to is this analytic translator or data translator role. And this is something that's often misunderstood. And the reality is every organization has people doing this today. They just may not be formally recognizing it. So, traditionally, while we didn't label it as such, we always knew, hey, who on the team is really good at talking to the business people about what they need and helping us figure out what we need to do here. That's being translator. Now, it was never historically somebody's full-time job, and often today still isn't. But because it's become such a heavy need, there are now folks who are beginning to have this as a full-time job as opposed to part of their job. So keep in mind, as I go through all of these things today, I'm using the term role, meaning it's a task that needs to be done. It does not necessarily mean that it's always equivalent to somebody's hired full-time just to do that role. There's still plenty of cases where people might split duties across some of these roles. The key is that you cover them. And as you scale, you'll end up putting people probably full-time in. But there's two big mistakes made with translators. The first is people think of this as more of a project manager. Oh, we just need someone to manage getting these requirements from the business people into the analytics team's hand. Bad idea. This is absolutely not a project manager. This is not just a tactical move the boxes. This is somebody who literally understands and can work with the business and has credibility, and can also understand and work with the analytics data science team and has credibility there. Two entirely different sets of skills. The second big mistake tied to that then is people think of this as a junior role and maybe an inexpensive role. I think it's the exact opposite. This actually should be some of your most experienced and most senior people. Why? Because only they'll actually both know the business and the technical side of your data and your systems and your business processes, but they'll have the credibility on both sides because they've been around and established themselves. The reality is no matter how smart they are, it's going to be hard to send somebody 3 years into their job into a vice president's office and immediately have them have that any real credibility that gets earned over time. So you really want to think about putting senior people in this role. And in my mind, the ideal is somebody who's actually been a director, VP level, who says, I'm just tired of all of the management of the people and the politics. I'd like to just get involved in project work again. Let them really focus heavily on doing these translation, because it comes in on the front end, defining the projects, and it comes in on the back end on the rollout in terms of the training and education on how to make use of the process and the outputs of those processes once it's created. And so who should be hired for this? The big question. People from the analytics and data science world who happen to really like and understand business, or people from the business side who really like and understand analytics? My answer has always been both of those can work. I've seen both of those work. I think pragmatically speaking, in most large enterprises at least, there are far more business people than there are analytics and data science people. So the odds say you'll probably end up with more people coming from business just because you have more of them to choose from. But I don't know that you have to necessarily give a preference to one or the other at all. I think you look for the people who are into the role, who would be good at it, and step them into it. I've also, for years, tried to come up with a better term, because I think if you say you're going to be a data translator, an analytic translator, it doesn't sound like something a VP would want to step into. It doesn't sound like an exciting role. As of yet, I haven't ever had anybody come up with another title that was descriptive enough to make sense that actually sounded any better than this. So I stick with it for the purpose here, because I think everyone kind of gets what I mean, at least when I say that. So the next role that's somewhat newer, I remember I hired the first couple people into this role on my team back around 2000, I'm going to say either 15 or 16, when I started realizing we were developing more and more analytic processes for our clients. This was when I was at Teradata. We're developing a whole lot of processes for our clients that they actually wanted to get deployed out to their end users directly, and they often just wanted us to build some kind of interface on top, and or enhance some of the interfaces they already had by adding some additional screens or functions into it. And so this is another type of translator role. This is somebody who obviously is well versed in application design and building, which is a discipline again in and of itself. but who also is interested in the nuances of analytics and what kind of output you get from analytics and how you might best interact with and display those results. And so this is someone who again, is a mix of a software app developer designer and someone with a good analytics data science background. And I can tell you, I've been guilty of this for many years. Folks like us who do analytics love to just hack things out. And I hacked out a lot of little applications that I gave to various people over the years. Did they work? Absolutely. Were they really slick? Did they look as good as a pro would have done? And did I follow the right design principles that an expert probably would have said I should have? No. And most of us would not. So this gets back to, as you start to mature, if you want your analytics to have maximum reach, eventually you're going to have to say, tossing something out quickly in a shiny app from R isn't going to cut it with business users who are used to sophisticated software. You're going to have to build them something that looks and feels a little fancier like they're used to. And so this becomes much more important. I think the newest role that's evolving rapidly, and this is probably just the last couple of years that it's really come to the mainstream, maybe even 2 to 3 or less, are these operations roles. And it started with data ops, not so much touching the data science and analytics directly, but then we've got ML ops, AI ops, et cetera. And this is, I think, another hybrid role, to be honest with you. There are classic computational patterns for traditional ERP type applications, reporting applications, and operational systems that companies run. And a lot of classic data ops people know very well how to optimize those systems to handle that type of processing and to keep things running. As we know, things like machine learning and AI, they have completely different profiles in terms of the type of processing that they do, even the type of processors they may use. For example, GPUs being used so heavily with AI. Point is, it's very different, in some cases, both hardware and mixes of hardware and CPU. And so this gets back to where you want somebody who's really well versed in data ops, but ideally they start to really dive deep into what's required and how do you tune those skills to help benefit a machine learning, AI, data science environment and process most. And I think that's where we're seeing these pop up. And again, a hybrid between an ops person and who understands data science, or I know some data scientists who love the ops stuff and move over into that. But this is a really key role. You cannot scale things to the level that is being required today without getting into some of this. And honestly, I think that cloud-based platforms almost necessitate this even more, because in the old days, like for example, we'd have a data warehouse, and that warehouse was paid for. It was hardware on our floor. In fact, the best thing to do was to keep it busy 24/7 because you're getting your money's worth. So if we had processes that were inefficient, that ran all night, as long as we weren't hindering others from running what they needed to, no one actually cared. So we would only be efficient enough. In a cloud-based platform now, where you're paying as you use those CPU and storage resources, suddenly the efficiency of the operations counts a heck of a lot more. So even if my thrown together process was getting things done fast enough on the, in clock time, meaning I got it done within an hour or within a second, whatever my time limit was, if it was horribly inefficient compared to what it might be if someone with an ops background tuned it, that could cost a bunch of extra money. So this is just becoming more and more of an important need. And then to tie this together, it's been amazing to see. I always talk about when I started my career, there was no career in analytics. There was no such thing. And in fact, I know even coming out of grad school, people were telling me, you're crazy to go into business. There isn't anything for you to do in business with analytics. And I went in there just thinking I'd enjoy it and expecting, as was typical, I'd probably maybe either have to be stuck in a manager role for my whole career, or I'd have to move to a pure business role. So I remember, in the early days, a lot of people would work closely with marketing, building a lot of marketing models, and eventually just go be a marketing director of some type in database marketing or some more analytically oriented marketing role. But that really wasn't analytics anymore, because that's the only thing you could do if you wanted a career path. Obviously, no longer true. We've got chief analytics officers, chief data officers, chief data and analytics officers all over the place, and that is absolutely awesome. However, as you start to grow a large organization, a chief analytics officer gets, as the title would suggest, it's a chief. It's high up there. They're getting stuck. They have to fight for the budgets. They have to manage the politics of the business changes that need to happen after these processes their team's building are getting put out there. So this is a really, really difficult, high-level strategic job. A chief analytics officer doesn't have time to put towards doing all of the project management of all of the individual projects being built any longer. But at the same time, somebody has to drive those. And what I'm calling a chief data scientist, I liken this a little bit like in the technology world. Often there's a CIO who owns everything. A CTO often doesn't have a very large organization. I know some where a CTO doesn't have any official organization, but they're kind of the lead technical expert who has a ton of power and a ton of say in what happens. They help make sure that the CIO's vision gets implemented. This is similar to what I see here. It's the chief analytics officer helps set the strategy, set the direction. The chief data scientist is someone very senior, very technical, who does not want to get into all the politics and pure management capabilities, but who can understand what that CAO wants and then translate into the detailed specs that the data science team needs to actually go and build it. The data engineering team needs to actually go build it and monitor it. And this, again, as of many things, we don't ever reinvent anything brand new for the most part. There's like in engineering organizations and research and development organizations, they've had roles like this, a technical fellow or an engineering fellow. If you go out and look, my first job at AT&T Bell Labs, there were these engineering and technical fellows who were immensely respected, who had few, if any, reports, direct reports, but they knew their stuff in their area. And this is really the analog here. And I think we'll see more and more of this where we need the technical senior analytics data science people alongside those executive, more on the leadership strategy side. And then we get into democratizing. This is another big expansion in the last couple of years around, well, let's take data science and analytics and push it even further out into the organization to lower and lower levels of people who have less and less and less technical skills and let them start to have at it. It sounds a little bit scary at first, but I remember a few years ago, and everything's a few years ago now, is one of the last conferences I spoke at live, and I think it was late 2019. I had talked about democratizing data science for a while. And the question after that talk was, someone said, Bill, I think we'd all agree that democratizing business intelligence and reporting is safe and reasonable to do today. But isn't democratizing data science, isn't that a little too complicated? Doesn't that go a little too far? And my answer, which I still stand by, is I think that was a question that wasn't framed properly. It is true that in recent years, people are very comfortable with basic reporting and business intelligence being democratized. That wasn't always the case. If you go back even as recently as late 90s, I can tell you that the early versions of these reporting tools that went mainstream, things like MicroStrategy, Business Objects, right before we even had anything like a Tableau or a Spotfire or anything, they were actually quite complicated. You had to know SQL really well. They were very technical. You had very technical people running those tools. There was no talk of democratizing the use and creation of the designer tools around BI. You would just deploy those reports out to the end users to run on demand, which is a very different scenario. But we've evolved it. This is where I go back to a cooking analogy. If you go back 200 years and you're living on a farm and you wanted to bake something as simple as a birthday cake, that wasn't simple at all. You had to go get all the scratch ingredients. You'd have your flour and your sugar and some milk and some, if you were lucky, you had some spices like vanilla you could add in, but you'd have to measure it all yourself from scratch. You'd have a wood or coal-fired oven that had no temperature control, that you'd have to kind of get to know your oven and where were the hot and cold spots and rotate that cake and get it out in 40 minutes, looking great and tasting great. That was actually very difficult. By the time we were in, mid 1900s, we already had, cake mixes, boxed cakes. I grew up with those. They're still around today. You add water, a couple eggs, or a little bit of milk and a couple eggs, put it in your perfectly temperature controlled oven for the perfect amount of time. Anybody's going to get a really solid cake out very quickly. Equivalent to the BI. We all agree, cake baking, basic cake baking is democratized BI. What about data science? Well, data science does go further, but let's take the cooking analogy first. If you said we're going to democratize gourmet cooking, people would say that seems a little bit crazy. But in recent years, we've suddenly had, between the combination of technologies, shipping speeds, and so forth, these gourmet cooking kits that you can go order. They ship you precisely measured amounts of all the ingredients with both written instructions plus videos you can go watch to tell you exactly how to mix it and cook it. And you can make a pretty darn good meal that goes way beyond your base skill level. we've kind of democratized gourmet cooking. Still, again, doesn't mean that somebody who does a bunch of kits is going to be able to create their own creations or cook as good as a chef. We still need the chefs, but they can do a lot more than they ever could have before. And that's sort of where we are with data science. Yes, it is more complicated, but today with all of the algorithms being able to be wrapped with the tools now, with the little palette-based interfaces where you drag and drop and connect inputs to outputs, someone does need to broadly understand what's happening, but there's a lot of guardrails built in so that they can actually build a much more sophisticated than they ever could have in the past analytical process, relatively safe. And it's much like those gourmet meal kits today. So it's not as bad as it may seem. However, whether you like it or don't like it, it's here to stay. The reality is you're never going to put the genie back in the bottle. Business people are going to continue to push the envelope with building more and more complicated things. And you can either fight it and lose or join them and help them succeed. And what I find ironic here is today there's a lot of data science organizations who really fight against the idea of letting people encroach on what they think is their territory, in part because they feel like it's their territory, in part they're worried they'll mess it all up. Okay, valid. But I go back to the early days when we started doing enterprise analytics. There was huge arguments between IT and analytics organizations because we needed tons of resources on the systems. We needed to use them in ways that weren't typical, and IT didn't like to give it to us. I can tell you, every team I ever knew of found ways to work around the limitations that IT put on us in order to get our work done. I literally at one point had a database server in a closet in our hallway where we would load data from our corporate system and put it in that server where we could do our analysis because we could set our own rules on it. There's always going to be people who will find out how to get that data and build those processes. So, and the argument I always use with the IT organizations, isn't it better to give the people the permissions to do what they need to do on your systems where you can monitor it, you can help them tune it, and you can lower the overall corporate risk? By forcing them to go do all these hacks out on the side, you don't have any idea what they're doing. We don't have any idea what risks they're exposed to, and it's clearly not as scalable. So when it comes to enabling citizen data scientists, I always remind the data scientists I talk to, I say, the biggest complaint just about you hear from practicing data scientists is how much time they have to waste doing really simple processes for the business that they need day to day instead of the quote cool stuff that they want to do. Here's a great way to offload that to those people. Now, will you still have to provide them some support? Absolutely. And you should. But providing them support over time, if you help them understand how to do it, you'll spend a lot less time providing them support as they build some of the stuff themselves than if you had to build it all on their behalf, which then frees you up to do more of what you want to do, which are the deeper analytics. So the key here is, as you enable this democratization, you first have to have processes where the experts from the data science analytics team have to review and check what was built by somebody before it could be deployed broadly. So there is a quality check there. Second, you have to curate the data and the algorithms they have access to very carefully. I always use an example of a churn model. Maybe you want to predict 30, 60, 90-day churn using a bunch of customer metrics. You can set up data sets that are pre-formed for that. Let a business user create their own model with fresh parameters, but they're basically pointing all the variables are safe to predict churn against their 30, 60, or 90-day variable and getting some fresh parameters. It's really not that risky if you curate the data and the algorithms and then you put the guardrails in place. Doesn't mean it's easy to do all of this, what I'm saying. Obviously, it takes time and it takes some strategy, but it is doable. So let's review these and then we can get two closing themes and we'll go into some Q&A. So what this really means is we're specializing across the analytics and data science process. So we start by defining our problems and the approach that we're going to take. We get the data data analytics translators in there, helping understand it, and the data science generalists who help figure out what mix of data and analytical methodologies are needed to farm it out. We then get people preparing that data. You've got, your classic architects, your data engineers. There's beginning to be multiple types of data engineers. Some of them are specializing in, real-time streaming pipelines. Some are specializing in cross-platform manipulations, et cetera. I think we'll see multiple types. I also predict we're going to have citizen data engineers ramping up here very, very soon as that field matures a little more. As we actually build our analyses, all sorts of data science specialists we've talked about, and people in AI, classic modeling, NLP, analysts, which I call more like a It's a professional who does analytics for a living, but more on the business side, more light reporting, a lot of Excel, a lot of Tableau, that type of thing. And then, of course, assistant data scientists who are maybe even a little bit later than that. And then when you go to deploy, these application interface developers who are helping put the front ends on them when they're done, these operations roles to tune it, make it efficient. And then again, the translators come in to help then with the training and deployment plans, et cetera. So we really have specialization within all of these different areas of the analytic process and multiple types within it. So to tie all this together, one of the things I hear especially when I talk to large companies today, the hot thing today seems to be data literacy. Everybody's struggling with data literacy. And I had a blog on this last year. Basically the premise was, if you're struggling with data literacy, that's great news. And I really believe it is, and here's why. It doesn't mean it's not painful. It doesn't mean the business isn't still beating you up. But here's the thing. Just a few years ago, nobody was complaining about literacy. They were complaining about they couldn't get the data they needed. They couldn't get the analytics they needed. They couldn't have what they needed to run their business. Now, data literacy complaints are around they have so much data, so much analytics, so much coming their way. They're not sure what to do with it all and how to interpret it. That's a real problem, but it's a second order problem. You don't get to that problem until you give them enough stuff that they're overwhelmed with it. So this is why it's good progress all around. So just keep that as the silver lining in this as you go through the battles here. But here's another really important point. Huge mistake made by analytics and data science people, which is thinking of literacy as a one-way street of reading or receiving the information that's been produced. And when the business is struggling, it's all, your quick answer is, oh, the business just doesn't get this. They need to get more up to speed on how to use this. They're just not prepared for what I've created. That could be true and part of the problem. But literacy, if you look it up in the dictionary, is both the reading and writing of information. So in our context, it's your delivery and your turnover of what you've done to the business people. That's an equal part. You might just as well be giving them stuff that's way too hard for them to understand, that isn't realistic. So just like in math, if you're talking about basic probability to a group of sixth graders with no statistics background or a group of PhD students, you're going to talk about probabilities at a very different level. Similarly, you have in your responsibility, if you're a technical professional, that if you're going to have data literacy, it's not just on your audience to receive and know how to read your information. It's on you to know how to write and deliver that information in a fashion that's appropriate for their level or their reasonable level of acumen. And if you can both meet in the middle, you can have a lot of luck. But don't put all the onus on the business to be ready for what you're giving them. You've got to put it on your own team to be ready to deliver. And then the final thought is, what really keeps up analytics and data science executives at night? And I can tell you, this is something a lot of people have only admitted to me, like one-on-one or over a drink. I've openly admitted, which is how I get them to admit it to me as well. I experienced this myself. There were many years in my career, even when I was managing teams, that since everything was still the same general type of data that I grew up with the same tools and so forth, I could have hopped in and debugged anybody's code on the team at any point. I might be a little out of practice, but I was confident that I could have gone in and done any of the project work anybody on my team was doing for many, many years. That's just simply not true anymore. The reality is there is nobody who can be an expert in R and Python and SAS, and who can be an expert in natural language processing and image recognition and classic response modeling and clustering, and who can be an expert in streaming data and in ERP data and in classic retail transactional data, et cetera. There's just simply too much. That's part of why we're having to specialize. All of these specialist roles come from the fact that nobody can know everything about all of this anymore well enough to do it all. And so I've over the years ended up managing people where I understood conceptually, let's take natural language processing. I've never done it myself. I get conceptually what it does. I understand the theory. But if somebody on my team who was doing an NLP project had gotten sick and the project needed help, I could not have stepped in and done it. That's incredibly, incredibly disconcerting initially. But we all have to get, whether you're executive or you're on the ground level, you got to accept that you'll never understand realistically everything at a world-class level across the pipeline of the process and anymore. The reality is today, we're almost chunking things up. The data engineers might not fully understand all the ins and outs of what the data scientists are going to do, and the data scientists might not understand all the ins and outs of what the data engineers had to do to get that data together. That's okay. as long as you're able to meet for the handoff. I think of it like running a track race where you pass the baton in a relay, right? As long as each of you understands when to put your hand back and what you got to grab onto, and then you take off running, it's okay. I think the difference is in a traditional track relay, normally everybody's doing the same thing one after the other. In our relay race, you've got, different people in the race doing something different, much like in a swimming, a medley relay where there's different strokes in the same race. But most of all, then for executives, accept and embrace that you'll never understand everything your whole team's doing, but that forces you then to do what you need to do as a leader, which is get out of the day-to-day management tactical and get into the strategy, get into getting the group's mission set and getting the organization buy into using those results. You shouldn't be down in the weeds. So this actually forces you to get out of those weeds and embrace the fact that you now have a big organization and go make it work. So a couple thoughts. All this complexity, it's here. Obviously, it's only going to get worse and continue. Don't fight it, right? Adjust. Accept that you have to rethink both traditional roles in terms of the scope of and span of roles that you need, as well as who's going to do what, and is it a full-time job, or do you have somebody doing multiple pieces of parts? You're going to be constantly adjusting these things as your mix of analytics requirements changes. You've got to focus often and ongoing on the skills mix and the roles within your team. Every year at minimum, you should be looking, what are the new skills coming down the pike that we're going to need so we can start ramping those up? What are the new platforms we're going to have to integrate, or the new tool sets we're going to have to use? Who are we going to assign to learn those? Are we going to go hire somebody new, et cetera? Enable those outside your direct organization. If you're the analytics data science organization, this gets into that democratizing. Enable the basic business analyst or the citizen data scientist to do more with what tools are available and what data is available enterprise-wise. And again, you have to put some effort in, but it's possible. And then if you are an executive, expect that discomfort from being completely dependent on your team. And if you're a part of one of the teams, expect the discomfort of being completely dependent on other teams in this thread, because none of you can really do it all by yourselves anymore and have it be as efficient and as scalable and as accurate as possible at an enterprise level as is demanded today. So with that, I'll thank everybody. We'll go to some Q&A. I'll just, if you have questions later, you're welcome to reach out to me here with my contact information. And these are just some of my books. And then if you like, I've started a webcast series. It's available also in audio on the podcast platforms, where I interview data science and analytics executives from across industry about their career and how they got into analytics and what they've done. I've been focusing the first couple seasons on Atlanta-based companies largely, just because that's where I'm based, but I'm starting to slowly expand the circle. So if you're interested, you can get the videos on a couple of different websites listed there, and otherwise through your podcast provider. And with that, I'll stop the sharing, and Murat will go ahead and go to questions. I think you're muted, Murat.
Oops, sorry. We have questions in Q&A, and the question about how about project program management specific to AI, ML, and DS?
Say it again. Well, here, let me open.
It's asking that how about project, and program management specific to AI, ML,
Yes.
DS?
That's a great question. It's really funny. I've actually been thinking that I should add a role, product manager, in what are the roles that are evolving, because as more analytics are being embedded and truly made into a product of sorts, even if it's only internal to a company, but it's something that's serving information and output to other parts of the company or to the company's end customers, it really does become much like a product. And you get back to, some combination of the translators and the project managers and all might be able to do a decent job of that. At some point, though, you might need actually a true product manager. This would, again, be another kind of hybrid role of somebody who spent significant time in product management and has those fundamental product management skill sets, but also then knows how to apply those and knows some of the nuances within the data science, machine learning world, which I think that there are some. So this one, especially for, say, digital native type companies, is probably crucial and probably already have it. I think for traditional companies, most I don't think have recognized necessarily a need for this. They're not necessarily yet, in most cases, thinking of their analytic processes as products, but I definitely see that trend. And I'm not joking when I say I had a conversation in the last 2 to 3 weeks with somebody about that we probably should add something like this. So in fact, I'm going to take a note and try and do that update here soon.
Nice. So next one is, which roles will attract less and less hiring in the future due to automation shift to some other priority, fad and bandwagon, etc. Which I don't know what is bandwagon.
So that's a good one. I actually think all the roles that I mentioned here are going to be here to stay. Now, the specifics of what someone in that role is going to do will change drastically. So I can promise you what a data engineer is doing today is very different from what a data engineer would have been doing 3 years ago, because there's more tools and they've matured further and there's more documentation. So, there a lot of stuff that was very hard to do a couple of years ago. There's probably a widget now that does a lot of that, but now they're building the next widget. So I think the key is, and it gets back to that athleticism. We're always going to have some type of new data needing to be used in some type of new way, or even existing data used in entirely new ways. And somebody with a data engineering type of skill set is going to be very valuable for that. They'll be doing things in a few years very different from today. So if you look at, is somebody in a role today who never updates their skills and never wants to change going to have a job? Probably not. But if there's somebody who's really smart, who's enjoying doing what they're doing today because it's a cutting edge thing, and they're looking forward to the next evolution that comes beyond that, I think they'll have a job, for the foreseeable future. I think the same is true, whether you're doing applications, whether you're doing ops, whether you're doing the data science itself. I look at a lot of people, even those who have stuck to a lot of the traditional modeling techniques, with all the new types of data that become available, there's so many new applications to apply those to, you're still keeping plenty busy. So I think the key is things will get automated, but then we do more. And that's wherein, we used to build for marketing purposes, we'd have one model for each campaign. We used to build a custom model for every individual campaign. We'd score it one time, pull a mail list a month before the campaign went out, and it would be done. We'd never reuse it. There was no reusability. There was no scalability. We'd always have to build a new one, because by the time we needed a new one, the data would have changed enough. You wanted to update. Point is, a lot of that you have no need to do today. The tools have automated a lot of this. Let's regenerate the data set. Let's update the parameters, et cetera. So a lot of what I spent my early years on, I would do a couple clicks and have that same thing today. And a lot of what people are having pain with today, in a few years, they'll be able to do much more easily. And I think where you really see that are some of the enterprise tool sets these days that have said, okay, we initially started with a palette to let you put together an analytic process from a logic perspective. But then the big problem was, how does someone then deploy it at enterprise scale? And they realized, we better put some hooks so that you can take this logic within my tool set and push it out into the platforms that may be running to be run at scale, and even possibly manage it from this platform that I built it in. The early versions were a little more siloed around, you were either building or you were putting into production. So these are the evolutions that happen. So I think if you're good and you're motivated and you're smart, you're going to have jobs, I think, anywhere that you want, anytime moving forward.
Yeah, I was discussing with a couple other data scientists today. Something came up. We're thinking about defense industry. Now, in future, it will be more useless to have a manpower. So having like millions of soldiers, they won't have a purpose. So you need more automation, AI power in the future, even for the defense industry.
Yes.
It is everything dynamics changing. So next question is, for somebody currently studying data science, what is the best way to decide specialty to pursue?
Good one. So I guess two things. I would say initially, if you don't know, don't pursue one yet necessarily. Pursue a general, start as a generalist, learn a little bit about a lot of things. And if you find one that jumps out at you, then go for it, right? That'd be like if you asked the doctors, how do you decide what specialty to do? Should I be an orthopedic, or should I be a radiologist? I don't think there's a right or wrong answer there. Some people are drawn to one or the other. So I'd say start out by getting exposure to as many types of data science as you can. You may decide, I love just being a generalist. I'm just going to stick to that. Or you might say, this specific area intrigues me, and go for it. Now, if you want to be very, let's just say, it's kind of like you start a company just because you want to sell it. You don't really care about the mission. If you want to be very transactional and say, I want to pick a specialty that'll pay off the most in terms of getting the biggest salary and having a career, I would say at any point in time, you could pick something that's pretty hot. Doesn't mean that that'll stay hot or be hot 5 years from now. You might have to switch anyway. So obviously right now, AI is super hot, and it was almost a decade ago, you wouldn't have, it didn't have much going on out in the business world. so you could specialize in that and become an expert. Who knows? Maybe automation means that in a few years there's something totally different. I'm not suggesting that'll happen for sure. I'm just saying that, do what you love, and you'll find really cool projects and companies that need that support. And in doing those projects, you might find something else you love and morph into it. And I know over the years I was able to, do certain types of analytics and then get a chance at some other type. And then I go, oh, this is great. I do that for a little while. And, you don't have to lock into just one specialty for your entire career. But the deeper you get into a specialty, then the more it's difficult to then change to another one. Just like, the orthopedist who after 10 years wants to become a radiologist, you're not going to want to necessarily be their first radiology patient, even though they have a lot of medical experience. You're going to want them to prove themselves again in their new field. But they at least have all the medical background to make that transition if they chose to do it, a reasonable one.
Yep. So next one, as a junior, how should I develop my career to become a CDO?
A great question. So if you want to be a chief data officer, chief analytics officer, or let's say if you're let's say we have some people who are more on the pure technology side, want to be a chief technology officer or chief information officer. I think it's really the same everywhere. You can not only care about the technical details. You have, while you're going to start early in your career, you should understand that. You've got to then start focusing on understanding the business environment in which you're operating and building your analytics. You've got to start to get to know those business people, become useful to them, learn how to talk to them, earn their respect, be a partner with them, because that's how you start to understand the bigger picture and focus on the strategy that'll get you elevated up those roles. If you're just stuck down looking in the weeds and looking at code and so forth, it's hard to move up the ranks too high, because once you get up beyond, say, senior manager level or assistant director level, you're going to have to be dealing with people and politics and budgets and things that really aren't technical at all. And some people just hate it, and that's okay. But if you want to get into those roles, you're going to have to put up with that stuff. And it's going to be a big part of your life and your job. And so the earlier you accept that and start to practice it, the more likely that you'll get a chance to have a role that has a little more of it in it.
Christopher is asking, he's taking analytics bootcamp online. Is there a specific field that's the best for entry-level positions?
I think this comes back to some of the stuff I talked about earlier. I'd say, not really. I always say, you want to be able to prove you know how to program. I don't care necessarily what language. Prove you're a really good programmer. You got to prove you know how to set up data and manipulate data. Again, not necessarily, I'm not talking like, data engineering, enterprise level processor. I'm talking about, I have a customer file and a transaction file. I get how I have to aggregate the transactions to customer level metrics to then, do something with it. Like, show that you understand the basic logic of data, and then that you also understand how algorithms work and generally how you would apply those algorithms. And if you can do those, whether it's algorithm A or algorithm B, or language A, language B, data set A or data set B, if it's back to that analytic athleticism I talked about earlier. If I'm confident that you know how to do these things in a general sense, and that you have a feel for the concepts, then I'll be very comfortable in giving you a shot to get trained on our specific database platforms, our specific tooling, our specific model types, if you have those general skill sets. And in fact, I actually prefer people who have a broad base of knowledge that then we can kind of tune to our environment, rather than someone who really only knows a couple of things very, very deeply. Because you worry when you hire them, what if we have a lot of language processing needs today and we solve those problems and don't have a lot more? What am I going to do with this person? If this is all they want to do and all they know how to do, then you could be stuck with someone that ends up either leaving or that you have to let go, which is unfortunate, as opposed to having people that have a variety of skills that do that work for you for a while, and when there's not as much need, they morph over into something else.
It's great. That's fantastic advice. I highly appreciate it. So thank you, Bill, for today's talk. And I recommend people to check your website. It's really great content, and they can reach your books, and they can reach your audios. I will just share the page.
Oh, do you want me to share the page?
I'm sharing it. I mean,
okay.
Yeah.
Yeah, and I'll just throw out, in February or March timeframe, I don't know the exact date, I've got another book coming out called Winning the Room, subtitle, Creating and Delivering an Effective Data-Driven Presentation. And so that book is a book with like 119 tips, 140 illustrations, that is all the lessons I've learned over a couple of decades about how do you take all this technical, complex information and then make it accessible to a business audience so that they get the general concept of what you found, what you recommend they do with it, and why they should act on it and be comfortable doing so, even though they really don't have a clue what you did. That's actually much harder to do than it sounds, and I'm sure anybody here who's trying to put together a presentation for business sponsors would know that.
That's great. We'll be looking for it. So thank you for your time. Thanks everyone for participating today's meetup. Hope to see you in next one. So we hope to see the bill for next events too.
Thank you.
Thank you.